Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice. Hi.
Oi, so they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, ways. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello, good evening, everyone. Yeah, so I would request everyone who are present with me right now, could you please write a +1 in the chat box so that I can see your presence, and then we can very quickly start. And also, let us wait for a couple more minutes so that other people can join. So let me share my screen till then. And can anyone please confirm in the chat box that I am properly audible and visible? Anyone? Yeah, so let us wait for a couple more minutes, and I'm opening up my Jamboard screen. If Yeah, so can you please write your name in the chat box, uh, and also give me a confirmation that whether I am properly audible and visible, and my screen is also visible. Okay, then let us start then, and meanwhile the other people will join. Okay, so we are having a series on SDE interview session. Okay, and those who are joining, please do a +1 in the chat box so that you can confirm your presence. Okay, so let us start finally. So we are presently doing this series called the SD Interview Preparation Series, and this was started the previous week. So basically, the motto of the series is to take up concepts which are frequently asked in interviews and solve a couple of problems related to that. So in the first week, we started with binary search, and then we progressed towards bit manipulation. Okay, so today we will be again continuing with our bits manipulation series only. So today I will be speaking about a very important problem which is very frequently asked in interviews as well. It is called all pairs awesome. Okay, so let me write that. So it is called all pairs awesome. Okay. So yesterday, or in fact on the day before yesterday, so on day before yesterday, we did a problem. I gave you a very important inequality regarding bits manipulation, where I said that you can represent A plus B in terms of A or B and A and B. Does anyone remember that inequality? Does anyone remember that inequality? Anyone? Yeah, and the students who are joining, can you please write your name in the chat box? Just do a +1 that will help me mark your presence, and we can then very easily continue. So I mentioned about an inequality called A plus B is equal to A or B plus 2 times A and B. Is there anyone in the audiences who knew about this inequality? In fact, this equality, this expression. So I discussed about this why this I gave the intuition and proving as well that why is this correct. Okay. So apart from that, we also discussed about other important things like consecutive XORs. What will happen if you try to make a consecutive XOR of all the elements? Apart from that, we also discussed about how to find the consecutive XOR of all the numbers between the range L to R. Apart from that, we also discussed about how to there was a question basically upon like what was the question? I have forgotten exactly. So the question was, let me just see what I did yesterday. Yes. Yeah, then we also discussed about certain GCC functions like built-in pop count and the way you can basically utilize those functions. And apart from that, we also discussed this problem basically. Yeah, if let's say you're given an array and that particular array contains all the number having even number of times except two numbers which are occurring odd number of times. So the question wanted you to identify those two particular numbers which are occurring odd number of times. Okay, so that was a question. So is there anyone who remember about that question and the idea about how we can solve that? So these are among the few topics that we did in the first class, and today we will be continuing with that itself. But today I want to focus mostly upon solving a problem called all pairs awesome. Is there anyone in the audience who knows about this problem, all pairs awesome? Yeah, hello Divyansh. So the focus of our today's session would be to find this all pairs or some problem. So in this problem, let us say that you are given an array, and that particular array contains n numbers. So basically, it means that n choose two number of pairs you can form from that numbers. So now you have to find the sum of the XOR of all possible pairs that you can form from the given numbers, and you have to return that sum. Okay. So how exactly will you try to solve this problem? By using interpolation. Okay. And you have to try to solve this problem in a complexity of n log n itself. So if okay, so how will you try to solve this problem? Anyone? Hello, Pavan. How are you? Yeah. So, Pavan, we are doing a problem called all sum XOR problem. Do you have any idea how we will try to solve that problem? So let me tell you that basically you have to utilize the concept of bits manipulation. So let's say you're given a two numbers a and b, okay, and what exactly does a XOR means? So XOR will basically means that if you are trying to a number will become one if either of the numbers are equal to one. Okay, so XOR basically means you add the position of the bits and do a modulus divided by two. If you are doing that, it means that this particular is a XOR of the number. And you have to return that sum. Okay. So, how exactly will you try to solve this problem by using interpolation? Hmm. Yeah, so can anyone tell me how will you exactly solve this problem? Hello Pavan, hello Divyansh, can you tell me how exactly will you solve this problem? So let me tell you the concept. So basically, let's say you are standing on any particular position, bit position, and so there are n numbers, and let's say you divide all those numbers into two parts. Okay, let's say you say a number out of n numbers, there are a numbers which are having the zeroth bit. We are considering the zeroth bit as a set, and a b amount of numbers contains having the zeroth bit as unset. Okay, so what you do basically, you divide those two numbers. Now let's say you take a particular number from the group A, and you try to solve that particular number with each and every element of the group B. So what will happen? Since the zeroth bit is set in group A and it is unset in group B, the XOR of these two elements will be equal to 1. Okay. And so how many combinations can you make from group A to group B such that you are making sure that all possible pairs are taken care of? So if there are A numbers in group A and there are B numbers in group B, for every element in A, we are XORing it with every element of B. So there are A elements in A and there are B elements in B. And the XOR of these two numbers is nothing but 1. So basically it means that for whatever bit positions you are doing, that particular bit position will contribute 2 to the power I to the actual answer when you are XORing. So the process becomes very simple now. What you have to do, you have to iterate uh, over all the numbers and through all the bit positions. Okay, so if you when you do that, what will happen? You try to make a count of all the set bits and all the unset bits for every bit position. So it means that let us say that you are starting from the zeroth bit. So on zeroth bit, you calculate all the number of On the zeroth bit, you calculate the number of integers or the number of numbers having the zeroth bit as set, and the number of numbers having a count of numbers having the zeroth bit as unset. Okay, let's say you call them P and Q. So now what will happen? You will multiply P and Q because that will be the number of pairs that are possible. And since you are standing at the zeroth bit, that will contribute to 2 to the power 0 to the actual answer. So what you have to do, for every bit position, you have to find the count of the unset bits, the number of count of numbers having unset bit at that position, and the set bit. Let that denote by P and Q. So what you will do, you will multiply P into Q into 2 to the power I for all the positions of the bit. So P into Q into 2 to the power I will be equal to, I will range from 0 to 32. We're considering that there are 32 numbers, and we will it for all the possible numbers. Okay, so this is the concept behind solving this problem. So let us have a look in the at the implementation as well. Yeah, so those who are yeah, so those who are joined late and those who are joining new, I would like to tell you that this series is involving. This series is called SD interview preparation, and in this preparation, every week we take a particular concept which are very frequently asked in interviews, and then try to do a few questions related to that. Okay, so today we are discussing about bits manipulation, and the next week will I won't be able to take this session. So after that, I will be taking on essential maths and stacks and queues. So there is a link of a course called Complete Interview Preparation, which is just attached with the description of this streaming. So that course is very well crafted, and you can take that particular course. And if you're trying to prepare for your interviews, okay, so that will help you to prepare for your interviews. So do kindly check out that course. Okay, the link is in the description itself. Apart from that, let us try to solve this question called sums on. So, does anyone have any idea about the implementation and how we are going to do that? I just explained the entire question, and in fact, what I'm doing basically, I'm sending you the link of this problem in the chat box so that you can also solve along with me. And if anyone has a code ready, they can send me in the chat box. Hmm. So I have sent the link of the question in the chat box. You can try to send me along with me, or so as I just described, what I have to do basically, iterate through all the 32 bits and all the n numbers. Try to find the count of the set bits and the unset bits, and then multiply both the numbers and also multiply it with 2 to the power I, because the contribution would be 2 to the power I in that case. Okay. Yeah, so this is a code basically. You iterate across all the 32-bit positions. You then count the number of bits having set at that particular position and the count of bits having unset in two variables called ZC and OC. And for all the numbers of the n, you multiply OC into ZC into 2 to the power I and add it to your answer sum. And finally, you return that particular value. So let us try to submit this problem and check whether it is correct or not. Okay, so there is a small compilation error. It says that we should be expecting exactly this should be. Yeah, let us see now. I suppose this should work. Yeah, so as you can see, all the test cases have passed. So therefore, this question is correct. So this was about all some XOR pairs. I hope everyone understood about this concept. So if you have any doubts, you can ask me. Yeah. And those who have joined late, I would like to request you to kindly write your name in the chat box so that you can confirm your presence. And apart from that, let me give you a small introduction about our series. We are having this series on every week, so you can join it at 9 p.m. And this will help you prepare for your interviews. And we also have a course called Complete Interview Preparation, the link of which is there in the description of this chat box, description of this video, and it is also pinned on the comment. So in case you're preparing for your upcoming interviews, you can try to have a look at that particular course. Okay, so this was about some of Zora of all pairs. Apart from that, we also have a lot of other important concepts related to bits manipulation. For that, what you can do is you can directly go to the A to Z sheet of strivers. Okay, and you will find all the GFG links there. So you can just scroll it down and you will find bit manipulation here. And in this bit manipulation topic, you will find various other problems related to topics like. So this is bits manipulation, and under bits manipulation, you will find topic called learn bit manipulation. So in that, under learn bit manipulation, you will find various GFG links. You can solve these problems about various small concepts related on bits manipulation. So if you are asked to check whether an ith bit is set or not, so what do you do? So let's say you want to check whether that particular bit is set or not. You do that. You do a left shift operator by that number of positions, and then you do a AND of one. Okay, so these are the small numbers, small concepts related to bits manipulation. Then there is something called to check if a number is odd or not. So you can directly do a AND operation, bitwise AND operation with one with a number. And in fact, checking for a number whether it is odd or not using bits is faster than doing the modulo 2 operation. In fact, you can also check if a number is a power of 2 or not. All you have to do is do a bitwise AND of that particular number with n minus 1. So if you do n and n minus 1, that is equal to 0. It means that n is a power of 2. Because in a power of 2, what happens? The ith bit is set and all the bits are unset. And in the number, and if a number which is 1 less than the power of 2, the ith bit is unset and all other bits are set. Okay, so when you do a AND of those two numbers, automatically everything becomes 0. Okay, so this was about if checking for bits is a power of 2 or not. Then similarly, we have counting the number of set bits. which can easily be done using the built-in pop count function, which we discussed in our first session. Then we can also check about setting and unsetting of the rightmost unset bit. Apart from that, this question, swapping two numbers using bitwise OR operation, is very famous and it is asked very frequently in interviews. Okay, so this is actually very easy. All you have to do is just remember three different types of operations and you can very easily do the problem. Okay, so apart from that, you can look into other topics from this same sheet as well. So yeah, and having such bits manipulation tools handy will often help you in other parts of your problem solving as well, which involves graphs or DBs. Okay, so this was about all the small concepts of bit manipulation. You can definitely check that out and do a revision. You will also find the GFG link there, so you can practice the same question on our platform as well. Yeah. So since we have very less turnout today, I would like to keep the session limited. So yeah, we discussed about this all pairs also. In case I suppose everyone understood this problem, we also solved this problem on the concept of all pairs also, and why we are multiplying the count of the zeros and the ones with 2 to the power I at every position. Okay. Apart from that, we discussed about all the very frequently small concepts on bit manipulation. Okay. So from the next session onwards, we will be studying about essential mathematics and stacks and queues, problems related to that. Okay. So if you are a student who are preparing for your upcoming interviews, you can try to check out our course called Complete Interview Preparation. And the link of that is in the very first comment and also on the description of our chat box. So that is a very excellently crafted course consisting of all the relevant materials. Apart from that, we also have a mock live DSA session on every Saturday at 10 p.m. If you would like to have your mock live interview with any of our mentors at Geeks for Geeks, you can sign up for that interview session as well. Okay, so do check out these. The information are all provided in the description. I hope these would prove out to be completely valuable for you. And in fact, if you would like to have anything else, recommend any type of content you want us to prepare for you, we'll do it for you. All you have to do is just write it in the comment your recommendation. Okay, so this was about, yeah, let's wrap up our today's session because we do have a very less number of audiences present today. Okay, so do revise these concepts properly, and in case if you have any doubts, you can write up in the comments. Okay, so I'll get back to it later. Okay, so mostly I suppose people will be watching the recording here. Yeah, so let's, yeah, a very good night and see you all in the next session. Bye bye.